So welcome one more time to the session. We will have another speaker. His name is, I hope I will say it right, Davi Nascimento de Paula.
Perfect.
And his talk is transforming REST APIs with Protobuf. So please.
Yeah. Hello, everyone. Good afternoon. Welcome to this session. Today I'll be talking about the kayak's journey into the Protobuf world and how we started using Protobuf in our REST APIs and some lessons we learned on this journey. To start with, let me introduce you to Kayak. At Kayak, we are a meta search for travel. So it means that we search hundreds of websites and travel sites to find flights, hotels, cars, and vacation packages. And as you can imagine, we do this at scale. We process millions and millions of searches, and we need to do it fast. To improve the results we get from the travel partners, we use machine learning services to optimize the user experience. This is a simple representation of our architecture. So when a client makes a search, it hits our backend services, it then starts searching a lot of travel websites, and then to optimize these results, we are sending these results to our machine learning services that will then process it and return some optimized data. And what is this optimized data? It can be ranking, it can be the calendar to identify when is the best time to book a flight or to book a car, or it can be many different things. And this communication happens over HTTP. So we have the REST APIs receiving the data, processing the data, and then sending them back to the backend service. We need to do this at scale, and we need to do it fast because most of our services are real-time APIs. The users don't want to keep waiting until our models return some results, and then it takes a long for them to process. No, it needs to be fast and super fast. And then we notice that the backend service is separated from the machine learning microservices. The backend is mostly written in Java, and our machine learning services mostly are in Python and in Docker. And what do we use to build this machinery? I am not a data scientist myself. I am a software engineer, so I work building these tools for the other teams, for the other data scientists, to then use the tools I build and then deploy their services. So our stack for machine learning is based on Flask. We have some custom libraries that we use. We call it a framework. So we use these custom libraries to productionize the models. So the data scientists, they only care about building the data science models and then encapsulating them into our framework. This provides some cross-team collaboration because then we alleviate the engineering pain from them, and we can standardize some practices across the teams. And then these applications are deployed as Docker images. So it's also easy to test, to build them, and to make sure that they are following some standards. And this is where we started to think about protobufs, because we started having some issues with our REST APIs. We had different teams building tools and deploying these applications, and we needed to have some kind of control and support them when they were introducing changes. So the journey starts with the problem. The question was, how can we safely introduce change to our machine learning services without breaking the API contract? As you saw, we are communicating over with REST APIs. So if the contract changes between the client and the server, this will break the application. And these are real-time applications. We will return some bad data to the users, and this is bad. This is really, really bad. We had stats, we had contract stats, we had a lot of safeguards to prevent that, but they weren't enough because they were complicated, they were hard to maintain, and they got stale super fast. And when it broke, it broke. Everything was broken, and no one was happy with that. But we had some constraints. First, the payloads are super large. If we need to rank a lot of results, we need to pass these results around. Also, these services are sensitive to latency. So if we were adding a lot of validations when we were sending and receiving the data, this would impact the response time. And then we started using Protobuf, and in the end, what we got was flexibility, because we started having a clear separation between what was the API schema and what was the application code. And also we got up to 50% in reduction in latency when comparing to JSON. This was impressive, and we are super happy with the results. Now I'm going to start sharing the 4 lessons that we learned over these years. I started at Kayak 2 years ago, and I started at Kayak working on this project. So these are the lessons we learned over these past 2 years. The first one is that it's super easy to start working with Protobuf. But what is Protobuf? Protobuf is a data serialization format created and owned by Google. So you can think about as of JSON or XML. These are data serialization formats. Protobuf is a different one. And what is interesting is that it's schema first. So it means that you need to declare the schema. You need to say, I have this message, and this message has these fields, and these fields, they are from these types. And if you want to use this schema, you need to follow the schema you defined first. Once you define this schema, then you can generate the code in multiple languages. The compiler can generate code for Python, C, C++, C#, Java, you name it. A lot of languages are supported natively by Protobuf. Yeah, let me show you an example of a simple Protobuf message. Let's say we want to create a message representing a user. A user will have an ID. This ID will be of type integer 32. Also, it will have a name that is the type string. And then it also has a flag called isActive, just to say if the user is active or not. If you see these numbers, these 1, 2, 3, they are not assignments to these fields. They are just saying the first field is of name ID and of type integer 32. The second field is of type name, and it is of name and type string. And the third field is a Boolean field with the name isActive, because then this will be later used to parse these messages, to serialize and deserialize these messages. We'll get there. And now let's say we want to add a field called address. An address will have a street, a city, a state, a postal code, and they will all be strings. But we want to add these fields to this message to the user, because in our use case, every user has an address. We can simply add a nested message to the previous message we created. So in our representation of a user, we will have the ID, a name, and also this isActive flag, plus the address representing where this user lives. Then to use these messages in Python, we need to compile the class. So we have this Proto-C compiler that is part of the Protobuf ecosystem that will take the Protobuf definitions and then compile it into classes that you can use in your service, in your application. And it's super simple. Once you do that, you will import these classes, and you can instantiate the objects with the values you provide. Then the next step is, okay, now we have now we have the object. I want to use this object in my REST API. How can I do that? It's also super simple. Let's say that we have a post endpoint. This is a simple Flask application, just it receives a user, it does nothing, and then it just returns the same user. So we can have a post endpoint named user, and if we want to parse this data, we instantiate an object called from type user, and then we can parse from string the value of the request we received, and this will populate an object with all the fields, with all the fields we have in the request. If we want to return it to the caller, we can also serialize this to string. Why? Because the object user is a binary object. It's a Python object. So we can use this to manipulate the data and do whatever we want. So it's not a string. It's not like JSON. JSON is a string, but in this case, it's a real Python object. If we want to call this API, it's also super simple. You can just instantiate an object of type address, you can instantiate an object of type user, and then you just send it to this endpoint as post. You just serialize this data to a string. When I did that at Kayak, I was super happy. I said, okay, yeah, it works. My proof of concept is working. Let's change the libraries. Let's change the framework. Let's spin up a service. Let's see if it works. And it didn't work because we have this backend in Java, but for some reason it couldn't communicate with our REST API. And we spent some time trying to identify what was happening, and we saw that the internal networking infrastructure and the Java framework we use, they couldn't handle the binary requests as we expected. So the solution was to encode this Protobuf messages as base 64. This increases the size of the request a little bit, but it's still useful. Another problem we had was, okay, we generated the Python classes, but where is my code completion? What is in the user, right? So if we are defining the types, why don't we have this in my IDE? And one of the reasons is that we figured out that we had to add another flag to the Python compiler, to the Proto-C compiler, saying, I don't want just the Python classes. I want the Python classes and the Python stubs. And this wasn't super clear when we started with. And this is to summarize this first lesson. It's super easy to start working with Protobuf, but the generated code has specifics for each language. We need to check the documentation and experiment with configs. Infrastructure details need to be considered when you are implementing this, and you need to make sure that your clients are on board with you. But it's easy to start working with it. The second point is, it may improve performance over JSON. I know I told you already about it, but let's check some industry benchmarks. LinkedIn published a very nice blog post about it. They did basically what we did. They implemented Protobuf in their REST APIs. They saw up to 60% improvements in latency. They saw an average increase in response throughput of 6%. Atlassian did the same, and they saw up to 80% reduction in payload size. Also, they saw 33 times faster P99 deserialization. So it was super fast to just deserialize the data they were receiving. And at Kayak, we found up to 50% in average response time. So from the moment we send a request to the moment we get the response back, we could reduce it by 50%. This means that we saved a lot of money, we saved a lot of time, we could adjust our infrastructure needs, reduce CPU usage, reduce memory usage, and so on. Why? The main difference is that Protobuf is binary, while JSON is text-based. Also, the typing is strict, so the parser doesn't need to understand and to identify to which type, to which integer or float to parse this data. Also, the parsing uses the integers I showed you in the beginning to define the fields, while in JSON it needs to figure out which strings match to the internal fields, and this takes a lot of time. And then, kind of as a summary, we have smaller messages inside because it's binary over text-based, and so with smaller messages, we take less time to send these messages through the network. Then we use less memory, and then in the end, we have an overall boost in performance. The takeaway here is simple. It may improve performance over JSON, but then with larger payloads will benefit more from Protobuf. But then we also learned that the schema versioning is still a challenge. One of the problems we had with flexibility was to know when when we could identify that we had the chance to break the API schema contracts. So we checked the Protobuf documentation, and it says Protobuf supports changing schemas without breaking existing services. Nice, this is what we want. It supports adding new fields, and it supports deleting existing fields. That's what we want. So checking back that Protobuf message. Let's say we check these isActive fields, and we say, it's not enough for us. What if the user can be just canceled or suspended, or we can create something called inactive? What if we want to describe more what is the current status of this user? No problems. We can create enums in Protobuf. We can have the status active, inactive, deleted, suspended, pending, you name it, you can define it, and then these will be used in your serialization and deserialization. And then you just add this status to the user message. But now you have a Boolean field is active, and you have the status field that is also representing this. We need to remove these active fields. And to remove it, you just don't delete it. You mark these fields as reserved. You mark the fields of index 3 as reserved, and you mark the field named isActive as reserved. Because if tomorrow I want to add a new field, I know that I cannot add the fields to the index 3 because the previous schema was already using the fields 3, or I know that I cannot also create a field called isActive. So it works, and then I don't have these fields in my messages anymore. When I generate the classes with Python, we see now that the user message, the user object doesn't have the isActive fields anymore, and it now has the status fields. And we are using the status enum that was generated by Protobuf. We didn't need to touch these classes to make this work like this. This is good, right? Because now our generated code represents the new schema. What is the good of using the new classes? Best thing is that the old messages are compatible with the new schema. Because if we send a message with the new schema, it will not contain the isActive fields anymore. And then the service that receives it, if they are not using the new schema, they will see unknown message, unknown fields, and will say, I don't know how to parse this. I will just ignore this. So the old fields will be ignored. It means that the services, they can still live with different schemas, with different schema versions. They will not break. If the data is needed, naturally you need to know how to parse this data and so on. But in general, the contract will not break. However, if you remove fields, you may break your codes, because as I showed, that field doesn't exist anymore, the isActive fields. What if you were using that field in your application, you updated the schema, you generated the new package, but you didn't update your code? For Python, this is a big problem because we don't compile the code before building. So it means that if you don't test your codes or if you don't have the tools, it will just fail at runtime. So schema version is still a challenge. So we need to know that new versions of the generated packages may break the application, and then you need to make and follow the rules to understand what is possible to do when updating your schema. This made us think we need to build custom tooling. This doesn't come out of the box. Like the way we want to work with Protobuf doesn't come out of the box. So we needed to build things for us. The first question was where to store these proto files. The documentation says this is not part of your application code. This needs to be stored separately. So we decided to store all the proto files, all the proto schemas in a separated GitHub repository that is definitely separated from all the application codes. But then there was a question, how do I distribute these generated packages? Then we built custom tooling to build the artifacts and then send them to the artifacts registry. And then this solves our old problem, because if we generate a new version of the schema, we generate the package, we send it to the artifacts registry with versions. So if my application was using the version 1 of the package, it will never change unless I don't pin my dependencies, and we should never not pin it. We should always pin the dependencies. So we pin the dependencies, we can build it every time and make sure that we are using the right packages. When we update the dependency, then we know that we need to update our codes. Then this is easy, solved, done. But still, we had problems on how to keep the consistency between schemas from different teams. We have different teams creating tools, creating machine learning services. They create things and they are inventive, and we need to say, no, you need to follow the rules. Which rules? There are no clear best practices for Protobuf. There are some, we found some, and there was one thing in common for all of them. They were all abandoned. There were tools from Uber, from other teams, and they all said, no, we are not working on this. We found some solutions, but there are some commercial and open source solutions. So we kind of adopted part of the open source solutions to help us with, but in the end, we built a lot of internal tooling. So code reviews were super important to share the knowledge across the teams and to share how we were expecting them to create these Protobuf messages. And also we created a lot of custom GitHub workflows to check the change to links and then check for formatting errors. So yeah, just in time, this is what I wanted to share with you, that custom tooling is key to improve developer experience. So if you want to adopt this at scale as a platform, you need to include a budget for tooling. Because commercial solutions exist, but at that time we weren't sure if we wanted to get locked into a vendor. Just recapping, it's easy to start working with Protobuf. It may improve the performance over JSON. Schema versioning is still a challenge, and the custom tooling is very important to improve the developer experience. That's it. Thank you.
Thank you, Davi, for your talk. I think many will switch to your suggested solution. And we have time for a question. So please raise your hand if you want to ask.
I'm just wondering what other solutions did you consider, and maybe you can elaborate more, because you stick to Protobuf, but maybe there were other contenders.
Yep. Well, XML was not an option because of XML. We could continue using JSON. We could compress JSON. We could first use JSON, define the JSON schemas, put them in a schema registry, and then we would make sure that the applications would be using this, we would be fetching this JSON from the schema registry. And then we could compress the JSON when sending the request and response and then decompressing it. But there was a lot of overhead. Defining the JSON schemas is not trivial. As we saw, the Protobuf schema definition is pretty okay and easy to understand, and it's native, and it's built for this. The JSON schemas, we thought that this would be like an add-on to this, and it could be, the teams could not use it if they didn't want to. So we kind of wanted to enforce it somehow. So the main alternative we considered was JSON and adding all of these add-ons to our ecosystem.
Okay, one more question.
Hey, thank you for the presentation. I wanted to ask, maybe you can share some actual numbers. What's the payload or the latency that it was before and after?
I can share this with you because we work at the same company, but unfortunately I don't. Well, I don't have the numbers right now, and yeah, we can talk later. But yeah, I don't have the numbers right now. But it's easy to create some benchmarks and see the difference.
Okay, so let's thank the speaker one more time.